my name is Lissandra. Welcome back to the Math Resource Center at HCC Mary campus. In this video, we will go over the real zeros of polynomials handout. So the question reads, find zeros or roots of the given function. Now, let's start with part 1. To start this question, we first need to identify the possible roots of this equation or function. To do that, we need to find the possible divisors of the term with a 0 degree. In this case, is the 15. So the divisors of 15 are plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. Now for step 2, we'll proceed to solve for the roots using a special case of synthetic division. For that, we'll put all the coefficients of each term in a row on top. When there is no number in front of the variable, we just put 1 for it, and then -3, -13, and 15. And we'll start trying with one of the possible roots found in step 1. Now let's start with +1. We just put the first integer down, and then we'll start multiplying for the number right in front of it. So 1 times 1 is 1, and we put it right here. Now we add these numbers. -3 plus 1 is -2, and then we'll multiply the -2 times 1. That's -2. We add this to -13 plus -2 is -15 times 1 is -15. 15 plus -15 is 0. The fact that we get a 0 at the end means that 1 is one of the roots of this function. Now for step 3, we already know that 1 is one of the possible roots. So we could say that f in x equals x minus 1. This is the opposite number because the root is 1, not -1, times, and then we can look at these numbers right here, and that will give us the rest of the equation. So we have x squared, because there is a 1 right there, minus 2x minus 2 minus 15 minus 15. Now we can factor x squared minus 2x minus 15 to find the rest of the zeros of this function. Once we factor that, we get x minus 5 times x plus 3. And to find the zeros, we just have to equal f and x to 0. Once we take each term and equal to 0, we end up with an answer that x equals 1, x equals 5, and x equals -3. And this will be the zeros of our function. Now for part 2, we'll proceed in the same way we did in part 1. So our first step is find the possible roots. Since we have 15, we already know that the possible divisors of 15 will be plus minus 1, plus minus 3, plus minus 5, and plus minus 15. Now, for step 2, we're going to perform the synthetic division. We already know how to do. So we'll put the coefficients, and then I already tried with 1 and -1 and it didn't work out. So we're going to go to the next one, which is 3. We're going to do exactly what we did in part 1. So we get 0 for an answer at the end, and we know that 3 is one of the roots of this equation. Now for step 3, we already know that 3 is a root, so we put x minus 3, and then we go ahead and copy exactly what we got from the synthetic division. Now once we factor that, we get x minus 3 times 3x plus 5 times 2x minus 1. And we could equal f and x to 0. Now we just equal each term to 0 and find all the roots. And that will be our final answer to question 2. Now let's move on to part 3. Let's look at the possible divisors for -4. For step 1, look at the possible divisors for 4 are plus minus 1, plus minus 2, plus minus 4. Now for step number 2, we're going to start trying with the divisors of 4 to find the roots. Now let's start with number 1. Since we get a final answer of 0, we know that 1 is one of the roots. Now for step 3, let's just state that. Now, since we get right here a polynomial equation, which is not a quadratic equation, we have to proceed to step 4 and do the synthetic division one more time. So let's do that. Since we already tried with number 1, now we're going to move on and try with number 2. And the numbers we're going to put on top are going to be the new coefficients of our new polynomial function. So 3, minus 1, minus 12, and 4. Once we finish our synthetic division, we get a final answer of 0, which tells us that 2 is also a root of this function. Now we can move up to step 5. Once we have rewritten the function showing the first 2 roots, we just have to factor the last piece of it. Now that we have factored the last piece, we can just equal the equation to 0. And now we can find the roots of the function. And this will be the final answer to part 3. Now for number 4. First thing is we find the possible divisors of 9. Now for step 2, we proceed to the synthetic division. I already tried with positive and -1, so let's go ahead and try with 3. Since we get a final answer of 0, we know that 3 is one of the roots of this function. Now let's rewrite the function stating that. Now that we have the function rewritten, we could just proceed and factor the last piece of it to find the remaining zeros. Once we do that, we could equal the function to 0. Now, moving on to part 5. Let's start by finding the divisors of 52 so we can find our possible roots. Now let's proceed to perform the synthetic division. I already tried with positive and -1, positive and -2, and positive 4. So let's try with -4 this time. Since we get 0 for an answer, we could go ahead and say that -4 is one of the roots of the function. Now let's rewrite it that way. Our next step is to factor the remaining piece of the function so we can find the remaining zeros. Now let's equal the function to 0 and factor the remaining piece so we can find the remaining zeros. Once we try to factor the remaining piece, we get that no real roots exist when we factor that. So the zeros of our function will be, but since we're talking about only real zeros, our only solution is -4. Thank you for watching this video. Make sure to like and subscribe and leave a comment down below if you have any questions.